Okay, guys, good morning. I know that we're going to chapter 6. We're going a little bit backwards. I'm not going to apologize. It's just the way that I see the progression going. Sometimes I have to jump around, so I do apologize for the jumping, but there is a reason for all of this jumping. Sometimes they misplace information in the wrong chapters, in my opinion. We're talking about exponentials, and we're going to be talking about logarithms soon as well. And basically, the logarithm is the inverse of an exponential. So before I can really truly teach logarithms and show you that they're inverses, I need to show you what an inverse is. The good news is that it's extremely easy. I mean, you're going to laugh at how easy it is. When we talk about inverse relations or functions, remember there is a difference. A relation, guys, is any set of ordered pairs, period. A function is a relation where there is only one y value for any particular x value. So if I had the points 5, 2, 2, 7, 5, 4, that is not a function. Because when x is 5, I had 2, and then when x was 5, I had 4. And I cannot have two different y values for the same x, okay? So that's what a function was, just to give you a brief little reminder. So let's go back to the definition. When we look, bless you, when we talk about inverse relations or functions, we are simply switching all domain values with all relation values? No, range values. Sorry. Range values. Okay? Now remember that domain, when we're talking about domain, we're talking about the x values. When we're talking, bless you, when we're talking about range, we're talking about the y values. So you are literally just simply going to switch the x and the y values. And that's it. That's how you find the inverse. Here's an example of an inverse relation. Okay? If we look at this, we have the original relation is 2, 3, 3, 5, 4, 7, and 2, 6. Those are the points of the original relation. If I want the inverse, guys, all I'm doing is switching the y for the x. I'm switching the y for the x. So it'd be 3, 2, 5, 3 now, 7, 4, and 6, 2. That's my inverse. I simply switch the x's for the y's. Does that make sense? Simple, right? Really easy. Okay, find the yes? No, that's what makes it a relation. The fact that I have a 2, 3, and a 2, 6 makes it a relation. It's not a function. It's a relation. Thank you. It is a relation, yeah, because of that. I can never have two different y values in the same for the same x value in a function. But this is a relation, and a relation is any set of ordered pairs. We're going to talk about how to get the inverses of functions now in a second. But right now, we're just dealing with inverses of relations. And a relation, again, is any set of ordered pairs. Thank you, sir. So to find the inverse of this given relation, what would the inverse be, guys? 5, negative 2, 4, negative 1, 3, 0, negative 4, 1, negative 5, 2. Done. That's the inverse relation. You simply switch the x and the y values. You just switch them. You invert them. It's the inverse. Does that make sense for relations? Simple, right? Functions are almost just as easy. Finding the inverse of an equation or function, remember an equation or function, kind of the same thing, okay? When finding the inverse of an equation or a function, it's very easy. Simply replace the x with the y and then solve for y. Literally. So, for example, find the inverse of y equals x squared minus 2. Okay, step 1. Replace the x with the y and the y with the x. So now I'm going to have x equals y squared minus 2. I switched the x, I put it to where the y was, and I put the y to where the x was. Does everyone see that so far, gentlemen? Promise? Okay. Now, step 2, solve for y. So I'm going to add 2 to both sides. And I have y squared equals x plus 2. How do we solve for y here, gentlemen? Square root both sides. So y equals plus or minus square root of x plus 2. Why did I put the plus or minus? Because it was an equation. Whenever I have to use square root in an equation, it must be plus or minus. Because I got to have a positive root or a negative root. Tell me that's not super easy. You just switch the x and the y and you solve. Literally. Literally. Does that make sense, boys? Okay. So what are the graphs now of the inverses? What are the graphs of y equals 3x minus 5 and its inverse? Okay. In this particular case, you could do one of two things, guys. Okay. First of all, you can go ahead and find the graph of the inverse and then graph both lines. So for example, you replace the x with the y, and then you're going to solve for y. So you would add 5, and then it's going to be 3y equals x plus 5, divide by 3. Y would equal x over 3 plus 5/3. So that is definitely the inverse equation. However, from what we've learned, is it easy to graph a 5/3 as a y-intercept? No, right? So what I would do, let me split this screen here for a second. What I would do is the following, my friends. Whenever they give you a situation like this, where they want you to graph the original and the inverse, what I would do is the following. Let's graph the original equation. I'll do this in red. The original equation. -5 is a y-intercept, 1, 2, 3, 4, 5. Slope is 3, 1, 2, 3 over 1, 1, 2, 3 over 1, down 1, 2, 3 over 1. That's the graph of the linear equation, y equals 3x minus 5. Is everyone with me? Okay, now, didn't I say, guys, that for the inverse, you're literally just switching the x and the y's? Right? So, what is this point right here? What is this point here? 2, 1, right? So what's the inverse of that? 1, 2. What's the next point? 1, -2. So what's the inverse? -2, 1. What's the next point? Yeah, or we could just do the slope, yeah. So this is basically up 1 over 1, 2, 3. So down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Up 1 over 1, 2, 3. Or you could have just kept going to every point and just inverted. And then that, whoa, that's going to be a lot easier to graph. And you see, there's my 5/3 y-intercept, right? Right, guys? It's just under 2. Does that make sense? Does that help doing it that way? If you can graph it and it's nice and easy, just graph it and then find the inverse. If I ask you for the equation, you're going to have to actually solve the equation, gentlemen. We good so far? May I get rid of that graph? Thank you. All right. Now, let's find the inverse of f of x equals square root of x minus 5. Whoa, where did the y go, guys? Yeah, very good. Thank you. It is f of x. F of x and y are the same thing. That is the range. That is the output. That is the answer. So I'm going to replace this f of x, this y, with x. And I'm going to replace the x inside of the radical with y. Whenever I need to find an inverse, I literally switch the x and the y spots. I switch them. If it's a relation, I just switch them and it's done because it's a relation. If it's an equation or a function, I switch the x and the y and I solve for y. How do I get rid of that square root, gentlemen? Very good. Thank you, gentlemen. Square to both sides. So I'm going to have x squared equals y minus 5. Add 5 to both sides. Boom. Y equals x squared plus 5. And that's a parabola. And this is accurate because a parabola makes sense that it is the inverse of a square root. Okay? Is that clear, guys? Yes, sir. I'm sorry, what? There is no y. This is the y. F of x is y. Remember, f of x is the output or the range. Any other questions, guys? All right. Thank you very much. We're going to do one more lesson now.